Right, cool. So we said in this video we're going to look at linear momentum, right? So when Isaac Newton back in the day, when he was doing his genius stuff, he defined something called momentum. And first he defined force. So he defined force. He said force is the rate of change of momentum. He said force is a rate of change of momentum. Momentum being defined as this. So he defined momentum as equal to mass times velocity. On his way to defining force as a rate of change of momentum. That's what he said. I was like, people are asking, what do you mean? What is a force? What is a force? And he said the force is the rate of change of momentum. But what is momentum? Momentum is given by mass times velocity. Those are the definitions that he came up with. So suppose that the mass of an object m is m, right? So if its mass is m and its initial velocity, so let me just write it, mass equal to m, initial velocity. If the initial velocity is equal to u, and its final velocity, let's say its final velocity is equal to v due to a force. So there's a force that was applied. The force increased the velocity from u to v, and the force that was applied on this mass was equal to F, and it was applied in a time t. By the definition of force, we say force is the rate of change of momentum. It means that, let's look at our change in momentum. Change of momentum, we know that our change of momentum then is going to be final momentum minus initial momentum. Final momentum minus initial momentum, right? What is the final momentum? Final momentum is also calculated with the same formula here, but it's going to be mass times the final velocity. So it means mv minus the initial momentum, which is mass times the initial velocity, which is mu. So this is the change in momentum, mv minus mu. So hence, when you say force is the rate of change of momentum, we are going to divide that by the time the change of momentum happened. The change in momentum happened in time t. So therefore, our force is going to be equal to mv minus mu all over t. That's what Newton said, right? Change in momentum like this. And what we can see is if we multiply both sides by t, we are going to have mv minus mu. Ft is equal to mv minus mu. And this quantity that we have just created, F times t, it is called the impulse. So impulse of the force, it is the impulse of the force on the object. Now when we look at this, we'll see that force is measured in newtons, time is measured in seconds. So we can either put momentum into units, newton seconds. It can be in newton seconds, or if you look at it from this equation here, mass times velocity, the units can be kg meters per second. You will see this more often than newton seconds, but they are the same. From this side here, you can actually see that they should be the same. The units on the left hand side should be equal to the units on the right hand side. The minus sign doesn't matter. It doesn't matter. The units are going to be the same here, and here it's going to be newton seconds. So pretty much that is what linear momentum is from Isaac Newton's definition. In the next video, we're going to talk about conservation of this linear momentum. So stay tuned for that video.